Hello everybody, welcome to section 3. Section is going to be on seismic waves. And first things first, how do we measure seismic waves? The details of this are not important. What you should know is that this is called a seismograph, which records the shaking of the earth during an earthquake or some other seismic activity, something which is moving the earth. Now, when you talk about different seismic waves produced from an earthquake, we have the kind that travel along the surface waves, and those that travel through the body of the earth, body waves. And the body waves have a lot of interesting qualities to them. We talk about first the primary waves, the fast-moving waves, the one that gets there first. These are compressional waves, things like sound waves. You can also think of a slinky as being a good example of this. So these are the ones that get there first, and where you have alternating pulses of compression and expansion in the direction that the wave travels. So the wave is traveling in this direction. We'll see compression and expansion in that direction as it travels, as opposed to something like an S wave. Oh, and a primary wave, of course, being like a sound wave can travel through any medium, solid or liquid. An S wave, however, undulates a little bit more like a snake. So you can imagine as a snake moves, it's in a wave pattern, but the waves themselves are not in the direction that the snake is moving. And we'll have some diagrams in a little bit if that's not clear. These are the ones which get there slower, shear secondary waves. Rock is subjected to side or up and down forces, motion which is not in the direction of travel for the wave. And importantly, this does not go through liquids. When a shear wave hits liquid, it doesn't transmit through it. This only goes through solids. These also typically tend to be more damaging than the primary waves. So this might be able to give a little bit more of a clear visual here. This is our primary wave on top. It's traveling in this direction, and the compressions and dilations, the waves are in the same direction as the wave is traveling through the earth here. As opposed to an S wave, it is traveling this way, but the waves themselves are in the vertical direction. It's not the same. We talk a little bit about the different kind of body waves here, P&S waves, primary and secondary. Probably will not be getting into as much detail on the surface waves. Do know that there are a few different kinds of these you could observe. So, on the seismograph, what would a person see? So there's this little needle running up and down, vibrating with the motion of the earthquake. This, on the horizontal, is time, right? This is a sheet of paper which is running this way to the left, and as it runs to the left, it hits this needle which is scribbling back and forth, recording these waves. First thing that we notice, the first motion on it, is the first primary wave which hits, and then, however much later, are the secondary waves. We have the primary and secondary together, we get the greatest amount of motion on the seismograph. And we can measure here just the distance, right, where we have 23 millimeters here, the amplitude of the biggest wave. And we can also measure time on this. The next section is going to be on seismic hazards.